So I'm going to explain a little bit about temperature. First of all, we know we've come across this standard unit for temperature. In America, they use degrees Fahrenheit. There's also actually a second one that people don't. There's Celsius, and there's also centigrade. I'm not sure if I'm spelling that correctly. I think I am. And these are actually not the same temperature scale, but they're very, 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 very extremely similar. So they pretty much can be interchangeable. But the unit for one of them is degrees C. The unit for the other one is just a C. But then there's also Fahrenheit. But the one that which is the most important for science, is this one, capital K, and that stands for Kelvin. Now, Kelvin is what we call absolute temperature. And we need to explain, why do we need this other scale? What was wrong with the original one first? I mean, I would argue this is better than degrees Fahrenheit. It's more scientific. 100 degrees C is the boiling point of water. 0 degrees C is the freezing point of water. This is all centered around the body temperature and stuff like this. So it's more scientific, really, to use this one. However, we need something. We need to think a little bit more about, what does temperature mean? If I have a solid made out of these particles and they're shaking, they're vibrating around fixed points, when I heat it up, they shake more. Now, the temperature is actually the definition of kinetic energy. Well, it's a measure of average kinetic energy. So temperature is essentially a measure of average, and there is a formula which relates them. So it's a measure of average kinetic energy of the particles. So if it's a measure of average kinetic energy of the particles, what would zero temperature mean? Zero temperature would mean that there is no kinetic energy, so that there is there should be no movement. But of course there is, because at 0 degrees C, we don't just have liquids, which are clearly moving, but we have gases as well, which are moving quite a lot. So we need to know, what is the temperature at which there is absolutely no movement whatsoever. So they did a few experiments to try to find out what that would be, and they found it in terms of Celsius or centigrade. It's about minus 273 degrees centigrade. I think it's probably 0.16 or something like that, but anyway, we'll say that. So then they say, well, we're just going to say that is 0, and that's where the word Kelvin came in. 0 Kelvin. Now, if we increase to 1 Kelvin, that is going to be minus 274 degrees C. So the change in temperature, if we're talking about the change in temperature, only when we're talking about changes in temperature, then 1 degree C is the same as 1 Kelvin. But of course, when we're looking at how hot or cold something is, when we're talking about change, we can say that. But when we're looking about how hot or cold something is, then we have to subtract, depending on which way what we're doing. If we've got minus 10 degrees C, we would have to add. Hang on a second. So to turn degrees C into centigrade, we would have to add 273, right? So if we had minus 273 degrees centigrade, we add 273, and that equals 0 Kelvin. So whenever you want to convert degrees C into Kelvin, you just add 273.
So once again, the reason why we do this is because the definition of temperature should actually be when there's no there's no movement. No movement at all. And this comes into play when we are comparing temperature against pressure. If we keep the volume constant of a container, and then we were to increase the temperature, and then measure the pressure of a gas, and we were to plot it, let's say we started collecting our measurements here at this temperature, and then we increase the temperature, we would see a linear relationship. And if you extrapolated it, which means draw the line backwards, we would see that it stops at this point, and that's only if the temperature is measured in Kelvin. Otherwise, it would go through the. Otherwise, it would look more like this. It would look like this. And if this is T in degrees C, that would be minus 273 degrees C. So we have to use a correct definition, correct unit for temperature in order for everything else to make sense. So that's what this means up here when they're measuring. When they say capital K, they're referring to temperature. And if you wanted to turn that back into degrees C, what you would do is just subtract 273 from the value. Okay.